method. Now, redox reactions can't be balanced through simpleness reactions, as most reactions can. They're a bit more complex. So first we start off by writing both the reduction and the oxidation half reactions with the respective species. And after that is done, we must balance all species or components within each half reaction, excluding oxygen, hydrogen, because those will be balanced later on. And then, after that is completed, oxygen atoms are balanced using water molecules, and hydrogen atoms are balanced using protons. And these protons will produce a charge. And in this case, this redox reaction is being balanced, if I haven't mentioned previously, in an acidic solution. So afterwards, those the charge has to be balanced, and the charge will be balanced using electrons. And this will be done for both the oxidation and the reduction reactions. And after all these species have been balanced for each individual half reaction, both of the half reactions must be combined, and the electrons must cancel out on either side. After combining these, repeated species can be cancelled out. And as I previously mentioned, this is taking place in an acidic solution. If this were to take place within a basic solution, we would add hydroxide ions towards the end, and in order to cancel out excess protons occurring on either side of the reaction, after we've combined the half reactions. After doing this, we would then proceed to cancel out any repeating species.
Today we're going to talk about galvanic cells, what they do, and how to identify different parts of the cell. So we're going to work with the reaction solid zinc and the ion of copper in aqueous form that yields the ion of zinc in aqueous form with solid copper. So first you're going to break up the two different half reactions. So we're going to do zinc solid yields zinc, the zinc ion 2+ plus 2 electrons, as well as the copper ion with the 2+ charge aqueous plus the 2 electrons yields the solid copper. After you've written that down, you can kind of identify which one is being oxidized and reduced. By oxidation is the loss of electrons, and so the zinc is going to be the anode because it is being oxidized. And then we can see that the copper is being reduced because it's gaining electrons, which makes copper the cathode. Next, we're going to talk about the salt bridge and which ions will neutralize which side. So the positive ions of potassium are going to neutralize the copper, the cathode, and the nitrate ions are going to neutralize the zinc ions in the anode. As you know, electrons flow from the anode to the cathode, so you can see that the electrons are moving through the wire towards the copper from the zinc. Next, we're going to find out what the E cell values are for each of the reactions. So we're going to write them both in reduction form just to see what charge they have. And to see the voltage that they have and to determine which one needs to be first in the equation. So the reduction equation for the zinc ion is negative 0.376 volts as the E cell value. And for the reduction of copper, it's going to end up being 0.34 volts as the E cell value. To find the total E cell of the galvanic cell, you're going to do the reduced minus the oxidized. So we're going to end up doing the copper reduction value minus the zinc reduction value. But to help kind of point that out, we're just going to show that the equation is actually flipped. So the E cell is going to be the reduced minus the oxidized. And from that equation, we can see that it's going to be 0.34 minus negative 0.76. And as the total E cell value, we come up with a positive 1.10 volts.